First thing is for the digital signature is the three purpose. A digital signature gives the receiver the reason to believe the message was created and sent by the claimed sender. So you don't want, again, the cybersecurity topic, we don't want to be trusting something that is not sent by the actual sender. It's kind of a repeat of the slide. Non-repudiation. With the digital signature, sender cannot deny having sent the message later on. He said that if it has been sent by that person, the sender cannot deny that he did not send it. It is actually a signature, meaning that it justifies that it has been sent. So it's a kind of a legal obligation with it as well. So this is what it means. Non-repudiation means with digital signatures, the sender cannot deny having sent the message later on. Integrity. A digital signature ensures that the message was not altered in transit. And how it's going to happen, you will see the visual diagram of it, that how it is being done that way. Digital signatures are commonly used for the software distribution, financial transactions, and if I move, and other cases where it is not important, where it is actually important to detect forgery and tampering in the document. Here is the example. There is two people who wants to send the message. Digital signature uses asymmetric cryptography, and by this time everybody knows what is asymmetric cryptography is, which means public key algorithm is employed on this one. So no same key in the symmetric one, same key will be encrypted and will be used for encrypting and decrypting. So what was Caesar cipher looks like, the Caesar cipher code that you did, same key, remember, either +6 or -6. So it's the same key, it's a symmetric algorithm that. But in asymmetric, how does it work? We will see that the very basics of asymmetric here. And then today, from the last week, because I was not able to show you, I'm going to show you how we can implement this kind of a scenario in Linux, in Kali Linux. We'll see that. Digital signature uses asymmetric cryptography, which means public algorithm is employed. And here it is. Bob generated these two keys, public key and private key pair. Private key, he will keep it with himself, and he will send the public key to whom? To Alice. So Bob will keep his private key to him. He will not even share it with anybody, but he will share his public key with everyone that he wants to receive the message from. This is a very classic example of asymmetric encryption. Private key is already kept by him. He will not give that key to anybody, but he will give the public key to Alice. And again, it's like a bank one. Now, Bob wants to send a message to Alice, and the message he wants to send, and keep in mind, in digital signatures, document does not get encrypted. Document does not get encrypted. It is not get ciphered. The document will still be visible by when it will be sent out. Okay. So what happens? So let's say Bob write a plain text message, says layoff at the Lakeview store will begin, or this is a private message he wanted to send out. So the first step, he typed that message. Second is that we are going to create a hash just that will generate a digest for that message that he created with some kind of a hashing algorithm. What kind of hashing algorithm he's going to use, we are not going to look at that algorithm, but with some mechanism he is going to generate the digest against that text. That digest will be like anything 938, whatever you are seeing on the screen. And then using the asymmetric key, he encrypts, using his private key, he encrypts that digest. The message will still be visible to everyone, but the integrity of the text will still be maintained, so it is not changed. So now he's going to encrypt that digest using the asymmetric algorithm, cryptographic algorithm. And again, we are not looking at what algorithm. There will be algorithms available in the market, but he will just only encrypt the digest using the private key he has. So from Bob's point of view, he has done his job. He has written the message, he has hashed he generated the digest, and then he used the asymmetric, he used his private key to encrypt that. So notice that the memo is not encrypted here. You can see there's a digital signature generated for which message? Only for the digest he generated the digital signature. So I just kind of highlighted it green, and you can see the message of this that he wanted to send it is still the same. Now, when Alice receives this message, before she do anything with the message, what she does, using the public key of the Bob, what she will do, she will decrypt the digest, and only Bob public key will be able to decrypt that digest. Okay, because before in the first slide when I was showing you the example, he has already given his public key to whom? To Alice. Everybody can have his public key. So when she receives it, she receives and change that into back to from the encrypted, she will convert it back to our digest. And now this digest will be hold for a second. Hold that in your brain for a second. Let's move on to the next step. So now assume that it is already been sitting aside as a step one of this process. Now with this message that she received, she will try to convert the hash algorithm for it, and the hash algorithm that he used to generate this digest will now will regenerate the hash again, the digest again. And if both this digest that he generated with the hash algorithm and the digest that she generated with the asymmetric cryptographic algorithm, both are same, that's why I put 1 and 2. This confirms that this message is being sent by Bob. So there is a whole process that I have explained. So both should match the digest that is generated by the hash algorithm, because of based on the text that he used, it will generate. And this is the asymmetric key. This is the digest that was encrypted, now getting decrypted using the decryption algorithm. Both should match, and that will make sure that the message is coming from whom? From Bob. So you understand the algorithm. You will generate the hash using the algorithm. You keep the hash aside. Then you generate the encryption key for that algorithm, and you keep that aside. And then Bob sent that. If the file is changed, the hash will not generate the same. And when she receives it, she decrypts the digest, one thing. And the second thing is she generates also the hash. Same hash should be generated, because if the date time is altered or the inside text of it is altered, what will happen? The hash will not generate the same. So both will match, and then she sees that the digest is both the digest and the encrypted hash that was generated are the same, and that makes her believe that the message is actually from whom? From Bob. So the message is not changed, and it is actually the same message, because even as smallest of dot is changed in the text file, the digest will not be the same, and that is why it is same. That is why the digest message. So there's a lot of things going on in this, but at the same time, it is maintaining three things. What are the three things which we saw? The start. Authentication, digital signature gives the receivers the reason to believe that the message was sent by the claimed sender. Next is sender cannot deny that he did not send it, because the hash was generated at that time and the digest was generated at that same time. Third purpose, integrity, the digital, once 1 and 2 are done, third comes automatically. The message was not sent and altered in its transit. Even if a hacker gets it, if he tries to change the file in the middle, it will change the hash, and then it will not be the same. This is uploaded to module 8 already. Let's complete this topic. Very small topic. Using digital signature does not encrypt the message itself. That is one of the biggest. So this could be an MCQ question on the or in the midterm. When using the digital signature, does it encrypt the message or does not encrypt the message? No, it does not encrypt the message. It just creates the integrity encrypted for that. It creates a digest for it. So this is how you will answer it. It will create a digest. So you will need to actually remember this entire diagram, the last diagram. At what stage what is happening? Digest is getting generated. The digital signatures are generated based on the digest, and then when the digest comes into the receiving end, it is hold it on in two ways. The digest itself will be holding on, and the message hash will be generated, and that's how they verify.